100 years ago, humanity's picture of the universe was astonishingly small. The stars that filled the night sky were thought to belong entirely to the Milky Way. Astronomers believed our spiral galaxy was the whole of creation, the complete stage upon which every star, planet, and nebula existed. The edge of the Milky Way was, to them, the edge of everything. It was a comforting thought, simple and contained, yet it unknowingly confined our imagination. Then came a turning point in 1928. An American astronomer named Edwin Hubble turned his telescope toward faint patches of light and made a discovery that changed everything. Those dim smudges were not clouds of gas inside our galaxy. They were entire galaxies of their own, immense star systems separated from us by unimaginable distances. But Hubble saw something even more profound. These galaxies were not static, they were moving away, all of them. The farther they were, the faster they seemed to retreat. The universe, it turned out, was expanding, stretching outward in every direction like the surface of a growing balloon. That single realization transformed human understanding. The cosmos was not small. It was vast, dynamic, and alive with motion. Humanity was no longer at the center, but a single drop in a cosmic ocean of billions of galaxies. Decades later, in 1997, another, Hubble, this time, the Hubble Space Telescope orbiting above Earth, looked deeper into space than ever before. What it found shocked science once again. The expansion of the universe was not slowing down under gravity's pull, it was accelerating. Something unseen, now called dark energy, was pushing galaxies apart faster and faster. It was as if an invisible force was tearing open the fabric of space itself. From these clues, scientists pieced together a cosmic timeline, tracing everything back to a single beginning, the Big Bang, 13.8 billion years ago. That number became sacred in cosmology, fixed, repeated, accepted. But today, that certainty is beginning to fracture. The James Webb Space Telescope, with its golden mirrors and infrared eyes, now peers deeper into time than any human instrument before it. And what it sees does not fit the story we thought we knew. Take M92, one of the oldest star clusters in the Milky Way. Its stars appear nearly as ancient as the universe itself, around 13.8 billion years old, perhaps even older. But how can that be? Stars cannot exist before the universe that gave birth to them. And yet, M92 seems to stand at that impossible edge. Scientists created thousands of computer models to test its formation and age, over 20,000 simulations. But the results kept pointing to the same unsettling truth. M92 might have formed almost at the dawn of creation, or even earlier, if such a thing were possible. It forced a haunting question. Have we misunderstood the age of the universe itself? And M92 is not alone. James Webb has found entire galaxies that existed just 300 million years after the Big Bang, far too soon for such mature, massive systems to form. They are bright, structured, and ancient-looking, even though they should be young and chaotic. These galaxies should not exist, not according to our models. And yet, Webb sees them clearly. So, could the universe be far older than 13.8 billion years? Some researchers now propose a radical idea, that the true age of the cosmos might be closer to 26.7 billion years. If true, this would upend everything we know about cosmic history, from the birth of galaxies to the rhythm of time itself. The evidence doesn't stop there. Consider the Methuselah star, HD 140283, one of the oldest known in the galaxy. Its age? Around 14.5 billion years. Older than the universe, according to standard theory. That cannot be coincidence. Perhaps these are not errors, but clues, signs that the cosmic clock we use is running on the wrong calibration. At the center of this mystery lies the Hubble constant, the number describing how fast the universe expands. Two methods of measuring it give two incompatible answers. The early universe suggests a rate of 68 km per second per megaparsec, while nearby galaxies show 73. This contradiction, known as the Hubble tension, refuses to go away. And if we cannot agree on how fast space expands, how can we claim to know its true age? James Webb keeps uncovering mysteries that defy our understanding of physics, quiet anomalies that whisper of something deeper at play. Every new image, every faint light from the edge of time, seems to challenge the very foundation of the Big Bang story we've built over the past century. What if the universe didn't begin once, but endlessly? Perhaps the Big Bang was not the first explosion of creation, but only one in a repeating cycle, expansion followed by collapse, death followed by rebirth. A heartbeat of the cosmos echoing through eternity. Each universe born from the ashes of the one before it, carrying faint traces of memory, patterns, energy, and structure that never truly disappear. And yet, another idea rises just as bold, that our cosmos may not be alone at all. Imagine a vast multiverse, a boundless sea of universes, each with its own laws of physics, its own histories, and its own version of time. In one, gravity may be stronger. In another, light may travel differently. And somewhere among those endless realities, perhaps another Webb telescope is staring back at us, asking the same questions, wondering the same things. If such a multiverse exists, then the galaxies Webb now observes, galaxies too massive, too organized, too ancient for their place in time, are not mistakes. They are evidence. Faint fingerprints of a greater design. Reminders that what we see is only a fragment of a story far larger than we can imagine. Some scientists believe the key may lie in the earliest seconds of existence, in the moment when the universe was no larger than an atom. They suspect that primordial black holes, formed instantly after the Big Bang, may have acted as seeds, anchors that gathered gas and matter, accelerating the birth of galaxies long before the first stars ignited. If true, it means the structure of everything, stars, planets, even life itself, may trace its origins back to these ancient cosmic cores. Others argue that the universe's mysterious fuel, dark energy, is not a fixed constant as once believed. It may be shifting, evolving, growing stronger or weaker as time unfolds. If dark energy changes, then the universe's expansion also changes, bending, stretching, and reshaping the cosmic timeline in ways that rewrite our entire understanding of age and history. At the smallest, most fundamental level, the mystery deepens further. The strange and unpredictable realm of quantum physics suggests that, in the first instant of existence, energy fluctuations were so powerful they could have birthed entire galaxies, perhaps even altering how time itself flowed. For a fleeting moment, the laws of nature may have danced freely, unconstrained by the order we know today. And through all this stands the James Webb Space Telescope, not just a machine of mirrors and metal, but a bridge through time. Its golden eyes reach across billions of years, collecting light that began its journey long before Earth even existed. With every observation, Webb sends us messages from the dawn of creation, whispers from a universe still learning to tell its story. Maybe the cosmos truly is 26.7 billion years old. Maybe time itself is not a straight line but a loop, or perhaps an illusion, a reflection of something deeper and more profound. Maybe our universe is not the story, but merely a verse, a single stanza in an infinite cosmic song that never ends. What is certain is this: James Webb is forcing us to confront the unknown, to question everything we thought was settled. It is showing us that reality is more mysterious, more elegant, and more alive than our equations can yet describe. We are witnessing the first pages of a new chapter in human understanding, a cosmic revolution. One that reminds us that discovery never ends, and that the greatest mysteries are not in distant galaxies, but in the questions we have yet to ask.